All right, let's look at this. So we have a velocity of 1 radian per second. Radian's about 60 degrees if you want to think of it that way. So we're supposed to, every 1 second, through an angle of 5 radians. Well, the first one would be up here somewhere. I gotta switch colors. It would be right here, somewhere in there, maybe a little further. And the velocity would be tangential. The second one would be over here somewhere, so that's 1. Here's 2. The velocity would be tangential. 3 is going to be over here. Velocity is tangential. 4. Velocity is tangential. And 5 would be down here. And the velocity is tangential. Now they want acceleration vectors. Acceleration's always going to point towards the center. All right, here's a graph. We can graph this now. What would its position be? All right, so if the angular velocity was 1 radian every 1 second, I know that every second it's going to increase by 1. So 3, 4, 5, at 0, 1, 2, 3, 4, 5. And what's the slope of that line? Slope is 1. It increases 1 every 1 second. So I would need to put a scale here with 1 somewhere and say that it was 1. Rank and order the smallest to largest angular velocities. The order is they're all the same. Angular velocity 1 equals angular velocity 2 equals angular velocity 3. Angular velocity is equal on all points of a rotating object. Now speed, that's our V's. 3 is way out there, so the order would be velocity of 3 is greater than velocity 2 and 1. Velocity 2 and 1 are equal. You can kind of get that out of V equals WR. The radius of 3 is greater than the radius of 2 and 1. Woo-woo? Woo-woo. All right, so be careful on your graphs here because they switch them up. We have to look at what we're looking at and where we're trying to get. So this is basically just position. Our new position is radians, and velocity is our new way of looking at it, angular velocity, excuse me. So basically, what's the slope of this line right here? It's negative, so I'm going to draw a negative line. What's the slope of this line here? It's 0, so I'm going to draw a line that's 0. Same thing for B. What's the slope of this line here? It's positive. So I need a positive line, or a positive horizontal line. Now the slope of these are the same, so this distance and this distance has to be the same, and don't start at 0, and I'm just guesstimating it out, and they seem to be like that. For 4, it's different. We're going backwards. So it's just the opposite of what we did. This line is negative, so I need a negative slope. Doesn't really matter where we start, but I could start at the 0 and have a line with a negative slope. Now this distance and this distance are the same, so I need a positive slope of the same magnitude, so I'm going to bring it back up like that. Moving over to this one, this is a positive value, so I need a positive slope. I need a positive slope line. So you can pick wherever you want to start, really, because they don't tell you where they started. Oh, they do tell us, sorry. You do start at 0, so I did this right. And then what's the slope of this line? It's a negative slope, which means it's accelerating. How do we do accelerating? It was going fast here and slow here. So I need it to go approach 0. So 0 slope at the end. Why? Because it has 0 velocity at the end right there. So this is a slight curve approaching a horizontal line. Woo-woo? Woo-woo. All right, now they want us to take words and make graphs out of it. So in the beginning, it goes clockwise, 4 radians per second for 2 seconds. Clockwise is negative. So I'm going to have to go, I'll go -2, -4. I'll go 2 and 4. So it goes -4 for 2 seconds. And then counterclockwise, which is positive, at 2 for 4 seconds. So I have to come up here and draw the best horizontal line I can for another 4 seconds. Now they want us to take angular velocity and take it back down the radians. And I think they say start at 0. They do. So if I start at 0, I need a slope of 2 for 2 seconds. No, excuse me, slope of 4. The second part is a slope of 2. So I need to get this down to -8 somehow. -4. We'll go 4 here, 4 and up to 8. And so a slope of -4 for 2 seconds would mean I'd end up at 8. Negative slope. And now I need a slope of 2 for 4 seconds. And that would get me right back to 0 again. That's be a +8, but it's going to take me a longer time to do that. So it's a little shallower slope. They give us acceleration here in the next one. What happens to A if the radius is doubled without changing the angular velocity? If the radius doubles, so I'm thinking of acceleration of A equals, remember back in the day it was v squared over r, which is now w, angular velocity r. I would get a change of 16 meters per second squared. The radius is doubled without changing the speed. If the radius goes up, the acceleration goes down. The radius went up by 2, so it's going to be cut in half. So 8 cut in half is 4. And the last one, the velocity is doubled without changing the radius. Velocity, wait, the first one I pointed to v. I should have pointed to r, my bad. Now we're doubling the velocity. So 2 squared is 4. 4 times 8 is 32 meters per second squared. All right, this is easy, right? So the direction would be positive there, negative there, positive there, and negative there. So just looking at velocity, we know it's plus, minus, plus, minus. Sorry, that's a weird plus. It's the old counterclockwise, clockwise thing that we should know by now. So if it's going in the plus direction and speeding up, 2 pluses is a plus. It's going in the negative direction and slowing down, 2 negatives is a plus. It's going in the positive direction and slowing down, a plus and a minus is minus. And it's going in the minus direction but speeding up, a minus and a plus is plus. A ball is rolling back and forth inside a bowl. The figure shows the ball at extreme left edge while it changes direction. At this point is angular velocity positive, negative, or 0. It says it's at the extreme left edge as it changes direction. the velocity would be 0. Is the acceleration positive, negative, or 0? Well, it's going to change direction, and it's going to roll back towards the right, which would be clockwise, and it's going to speed up, so it would be positive. Down here at 9, they're showing our acceleration vectors as it rotates this way. My acceleration vector seems to be getting larger, so it's speeding up. My acceleration vector, as it goes this way, are staying all the same size, so it's 0. And my acceleration, as it goes this way, are getting smaller, so it's slowing down, which is negative. Woo-woo? Woo-woo. That was easy. All right, these are easy, right? We're going from velocity to acceleration. Slope of a horizontal line is 0. Slope of a positive, it's a positive slope, so I have positive acceleration, and then back down to 0. I have 0 in the first part here. I have negative. It's pretty big, so I'm going to drop it down a little further than what I did on the first one. And then back to 0. And the last one, positive. These all look to be about the same to me-ish. So I am going to guesstimate that, maybe I missed there, should have come up a little bit. These are all about the same distance away from 0. And this is going to go back to positive again. Woo-woo? Woo-woo. All right, I love these. So what they want us to draw graphs, not with words, but a picture. What's going to be the velocity on this first leg? Is it going to speed up, slow down, or stay the same? I would argue it would stay the same of whatever velocity it has, and it would be rolling with a positive velocity. And I'm just going to give it a section here before it hits the hill. And then as it comes down the hill here, section 2, it's going to speed up in the positive direction. So I am going to make it speed up in the positive direction, and segment 3, I feel like it will go at a constant velocity again because there's nothing there. So now I've got to work my way down. This first section, slope of a horizontal line, is 0. There's no acceleration. And then it has a positive acceleration. It's speeding up down that hill. And then back to a 0 acceleration because it's on a flat surface. So section 1, 2, and 3. 1, 2, 3. 1, 2, 3. Woo-woo. Bye-bye.